Hey, good morning, everyone. Thank you for waking up and dragging yourself here, something that's going to get harder and harder as the week goes on. I appreciate it. My name is Kate Gregory, and I was trying to figure out exactly when I started writing in C++, but I didn't know it was going to be like a momentous occasion. And but I'm going to declare that it was 1987, because then I can say I've been doing it for 30 years. And in that time, I've learned an awful lot. And I like to tell my children the only thing better than learning from your mistakes is learning from someone else's. And that's kind of what this is all about. So let's start with a show of hands, not counting the title of this talk, the abstract of this talk, or Monday's keynote. How many of you had heard of the C++ core guidelines? That's pretty good. That's about 3/4. I'm happy about that. How many of you have been to GitHub, to this URL, just once and looked at it at least once? So that's less hands by dramatic factor, like about 1/3 of you. How many of you have, again, once changed the way you code something or persuaded someone else to change the way they were going to do something, drawing on a guideline? That is a really, what I'd call a smattering of hands. Okay. So my purpose for this hour is to change that last hand. Okay? And I understand it's daunting, right? There's like over 500 guidelines, and memorizing them all seems impossible. Starting at the top and reading also seems impossible. So what I thought I'd do is I'd pick out a collection of guidelines and talk to you about them. They look like this. There's a bit of a categorization. This is functions, this is classes, this is expressions, blah, blah, blah. And there's all links, and they have letters and numbers in their names. So when I talk to specific guidelines, I'm going to call them out by their letters and numbers, and you can find them that way in the markdown. Who's on Slack, the CPP Slack? Okay, that's not enough hands. You should all be on the CPP Slack. You can ignore it if you're not interested right now. Think of it the way you think about Twitter, like just step in for a moment and see what's happening and step out. Don't try to catch up. But one of the things that happens a lot in Slack is people say, should I A or B? And so one of my hobbies is when I see that, I'll say, well, the guidelines say you should B because reasons. And then people say things like, but there's no speed difference. It's like, what? So let's be clear about what the guidelines are supposed to help you to achieve. Some of them really are because A is faster than B or vice versa. But many of them are for completely non-performance related reasons like readability or preventing bugs or whatever. And I picked up 5 reasons that I think are pretty prevalent reasons, and then I chose a couple of guidelines for each reason. So I'm not going to show you my top 10 guidelines or the 10 most applicable or the 10 easiest or anything. I just came up with these 5 reasons and found 2 guidelines for each reason so that you understand the motivations of the people who are writing these things up for you. Okay? So let's start with the bike shed. For those who are unfamiliar with the metaphor, I'm an engineer by trade, and when engineers design nuclear reactors or bridges or incredibly complicated things, submarines or whatnot, and then they bring their plans for approval, by and large, all the non-technical people are like, oh, that looks good. But as soon as you have something that has very low stakes, like a shed to keep bikes out of the rain, suddenly everyone has an opinion, everybody knows everything about it, and we argue about that for 6 hours. And so there's a couple of guidelines that are really just about, oh, for heaven's sake, make a decision and move on. So let's start with this one. I need to write a constructor, and some of my member variables have sensible default values. How should I make this happen? I could write a default constructor, doesn't take any parameters, and it gives default values to all the parameters. Or I could use semi-new in-class member initializers. And there's also the matter of whether or not you construct, in general, an initializer list for constructors. So here's a class. It's made up, but it's made up based on reality, right? When things grow over time and other people come in and do things, especially when they don't fit on a slide and these constructors are actually several hundred lines apart in the same file, you get this kind of behavior. So the default constructor for simple here gives C a value of 3. So that's obviously the default value for C, right? Except that the 3-argument constructor, if you don't pass a value for C, it'll initialize C to -1, and the 1-argument constructor will initialize C to 0. So 3 different ways to make a simple without specifying what you want for C, and 3 different possible values for C. And you can tell that wildly different people did this because whoever did the one argument constructor doesn't even know about initializer lists, right? That's a different guideline. Instead, you use in-class member initializers. Now you're writing less code, yay, always good, and you're consistent. A lot of the guidelines are about taking away opportunities to be inconsistent, right? So if you're a disciplined person and you have a wonderful test suite and you have code review and everything else, you would have caught that inconsistency on the previous slide. Now there's no chance to be inconsistent. The defaults are in the in-class member initializers. And I like to go one step further and instead of empty brace brackets, use default for that constructor. If I had no other constructors, this would put me back in the no user-defined constructors world. And according to the guidelines anyway, there's apparently a perf benefit to this as well. To me, the big benefit is we don't argue anymore. Yes, they are equivalent. Yes, you are disciplined and wonderful and would never become inconsistent. I get it. We can just stop arguing and just do it this way. Okay, some other people argued for a long time. Let's just do this. And it may prevent some bugs, and it may make your code faster. Similar argument, I got 2 versions of the same function. One's going to use 2 numbers, one's going to use 3. Should I write 2 different overloads, or should I write one function with a default argument? So here's the 2 overloads version. What am I simulating? A nuclear reactor, apparently. And I can take a pair of doubles, A and B, and a fudge factor, or just A and B. And it turns out that because I am a consistent and lovely person, I've implemented the 2 argument one by calling the 3 with a hard-coded value. Okay, you can read that. You can see the difference between the 2, right? It's very clear when I call the 2 argument version, fudge factor's 1. That's great. But not everybody writes it like this, especially when they start out small. Like they start out like 5 lines of code, and one of them multiplies something by the fudge factor. And then we feel sorry for the poor little computer, and we're like, why should I have a line of code that's multiplying it by 1? Like, that's dumb. So I'll just take that line away. We also take away things that add 0 and that kind of stuff. And then that causes the 2 versions of the functions to diverge. And even if you're absolutely disciplined and they never do diverge, can anyone else really be sure that they have not? So this is fine, but I have 2 different 700-line versions of the functions, and it's up to you to figure out where they differ, not so fine. When you do it this way, it's very visibly obvious, right? You can't always do this. Not all 2 versus 3 argument overload situations can be resolved with a wave of a default argument. But if you always do it where they can, then when you don't do it, you're also communicating, right? Again, this is mostly about not arguing. It's mostly about skipping the bike shed, okay? You could argue long and hard about how disciplined and consistent you are, or you could just do it this way. It makes the difference clear, and you can't get inconsistent later. So let's get to the parts of C++ that could hurt you. These exist. We try to tell you, you'll be sorry. So who's met this? It says define and initialize member variables in the order of member declaration. Yeah, that's bringing some pain back for a handful of people, and I bet it was quite a long time ago. You know, this particular pain sticks with you for a long time. So here's a class you probably would never write. I am taking an integer parameter and I'm incrementing it as I initialize each variable. And it's sort of an interview question, you know, what would the value of x be after this constructor runs? And we assume that code runs in the order that it's written, so we figure, well, it'll initialize, what am I passing in, 0? I'll increment the 0 up to 1, and then I'll initialize a to that, and then I'll increment it again to 2, and initialize b to that, and then I'll increment it again to 3, and initialize x to that, and that's not correct. Now, some people want it to be undefined behavior because they memorize that if you ever see 2 plus pluses on the same line, that's undefined behavior. It's not. This is beautifully defined, very clear. Well, if you read standard E's, we'll initialize a, then x, then b, because that's the order they're declared in the class. Okay? So the guideline says don't lie. Write your initializers in the order they will execute, since you can't control it. But there is a side effect, which is, what, you mean if people rearrange my variables, my code might break? Yes. And the plus plus thing is totally fake, but in the wild, I have seen pointers being initialized, new fits on the slide, but using a smart pointer would change nothing. And then something being initialized by calling something on the pointer. And again, if they change order, that's a very badness. And I have seen first name and last name being used to initialize full name. Some of you may know a piece of lore called never use member variables in initializer lists, only ever reuse the parameters over and over again. And if that's a piece of wisdom that's been handed to you, it's for this reason. There are tools out there that will put your variables in alphabetical order. There are newbies who are learning a way around the code base who will decide to put related things with related things. There are an awful lot of reasons why your variable declarations might change order. And ideally, just knowing that this exists will cause you to write stuff in a way that you're not vulnerable to it. But if you have to, at least you will have done it right the first time. The order will match reality, not the order you happen to think of writing them down in. And it may be a clue to the other people in your life. Don't rearrange the variables without rearranging your initializers. This guideline is a vague one. I mentioned my original training was in chemical engineering, and we passed around jokes in those days, was before the internet, on literally mimeographed pieces of paper, and there was this big long thing about pipe, which is hilarious. It starts, pipe is a long hole surrounded by metal. And among other things, it said that long pipe should be labeled as long pipe if it's over a mile long, but any pipe over 2 miles long should also be labeled not just at both ends, but also in the middle, so you didn't have to walk all the way to the end to find out it was a long pipe. So in the same spirit, what does it mean to keep the number of function arguments low, right? Like 27 is probably not low. You probably shouldn't have to walk all the way to the end of 27 to find out there was a lot of arguments. For the sake of the slide, I'm going to make 4 a lot of arguments, and I understand that it might not be, you might not need to be quite this strict, but you can even see the effect with a relatively small definition of low. It's a function called area that takes 4 integers, and you can guess by their names that it's sort of an xy followed by another xy. But when you see them being called out in space, 1, 1, 11, 21, it's easy to forget. Is that the top left corner and the height and the width? Or is it the top left and the bottom right? Or is it the top right and the bottom left because people are strange? Or what's happening? Maybe it's both x's followed by both y's. If you make up an abstraction like point, which is hardly a difficult abstraction to invent, now you can have your area function take 2 points. And that tiny change, and it's super tiny because I don't even have to type the word point anywhere, right? It's being initialized from this initializer list of integers. The grouping is obvious. You're not going to think maybe it's a point followed by a height followed by a width. It's clearly 2 points. And these abstractions may have value elsewhere in your life or not. Imagine that I have this class, and for the purpose of our discussion, it doesn't really matter whether details and rep are solid objects or pointers or references. It's not important. I need to make a customer. Which of these 2 ways of making a customer would you prefer? The one where you pass in the person part and the sales rep part, or the one where you pass in 7 strings, right? So it's just about reducing that cognitive burden. Maybe you'll invent a useful abstraction like point. That'd be cool. And it's possible you can even make your code more maintainable. So our area code was taking obviously 2 two-dimensional points. If we move to 3-dimensional points, we'd have to take x1, y1, z1, x2, y2, z2, and we can't fix that up with default arguments because that z's in the middle, or z for those of you with local locales. But if I made it points and my constructor for point has a default value for the z, then I actually wouldn't need to go and change the code. Right? That's a minor one that rarely happens. The big deal is really about not making people remember which of your 13 parameters is which, especially if they're all ints, which often seems to happen for those people who do this. Now no one's going to say don't write functions anymore. I'm just saying don't have a whole ton of arguments to them. No one's going to say don't use constructor initializers anymore, just saying be careful about the order. But there are parts of the language where we really want to say, don't do that, okay? So I love this guideline. First of all, because it's 4 words long. A lot of things in guideline land and standard land are a little on the verbose side. And the other thing, it doesn't say prefer. It doesn't say avoid. It doesn't say when there is a choice, like we did with the default arguments. It says don't. Let's take a look at this class. This is a made-up thing. What have I got? I've got two private numbers and a calculation, which doesn't change either number, calls me some kind of integer result. I have a constructor, I have two non-const functions, and a const get value. And you can guess, because it's been written in a way that's consted the things that need to be const, that service 1 and service 2 change number 1 or number 2 or both. In fact, it's not outrageous to expect that service 1 changes number 1 and service 2 changes number 2, right? And I'll tell you that all get value does is call long, complicated calculation. So this class is minding its own business. This class is const correct. Okay, but somebody notices that this class is causing performance problems because of good old long, complicated calculation. And so they decide to add some caching. So now we have the cached value, and we'll initialize that to 0. And in this universe, the only thing that can change our cached value is to change the values of number 1 and number 2. If you want, you could have the constructor actually also figure out the cached value instead of just making it 0. So this code is still telling the truth, right? Service 1, which is non-const, is changing number 1, and it's also changing cached value. Service 2, which is non-const, is changing number 2, and it's also changing cached value, and get value is still being good. This is a pattern that works if you have more reads than writes. So for example, to choose something that's not a complicated calculation, what day is it today needs to be updated on your display like all the time, but it only changes every 24 hours. But of course, the world is full of things that are the other way around. They change all the time, and you only look at them once in a while. So if you have a group of people who are all updating their timesheets every half hour or so throughout the working day, and their manager maybe only looks at their timesheets once or twice a week. So you have, orders of magnitude more updates than you do reads. So in that case, what you do is you add a signal that whether or not your cache is valid, and you just invalidate the cache on a write. So if you want to change number 1, that means the cached value is no good anymore. You want to change number 2, that also means the cached value is no good anymore, but we're not going to do the calculation. And then when somebody wants the value, well, do I have a good cache? No, okay, I'll do the calculation. So that's fine. It's good code. Small problem with it. Anyone see the small problem with this code? It doesn't compile, yeah. So it's like, there's no runtime errors though. Like, you got to give them points for that. We've said that get value is constant. It's clearly changing some member variables of the class. And this is where people are like, I know, we'll cast away const. Actually, there's a solution people tried before that. Let's just throw away const correctness. Right? Let's just say get value isn't const after all. What the heck? It's not, apparently. Compiler says. When I was teaching Intro to C++, there's this whole thing where people stop doing any thinking at all and just try to make the compiler happy. Just add stars and ampersands until the compiler shuts up, and they don't really think about what they're trying to achieve. And that's sort of the deal with taking off the const. Like, oh, am I not allowed const there? Okay, I'll take it off. And then you think you made your code good. But of course you made your code bad, right? Because we had this design that said, get value doesn't really change anything. Okay. So the old solution then would be to cast away const. And I'm not showing you code because you're not supposed to cast away const. But basically you make a thing called capital T this, that's the tradition. And you const cast so that it's a non-const, what's our class called? Stuff. So non-const stuff, and then you could say this points to number 1, number 2, or whatever. Problem with this, A, it's ugly as all get out. Right? You have to write all kinds of extra stuff, you have to have indirections, blah, blah. It's hard to read, hard to write. Your header file is now lying. Your header file says get value doesn't change any member variables of the class, but it does. And it actually has the power to change any of them. Right? Like you could write number 1 equals 0 in the middle of get value and it would compile. So you have an ugly, and slower approach that makes your header file a lie and could cause weird bugs that no one's ever going to look for. Gee, I don't know why we don't want to do this. Oh, I know why, because we can't think of anything else to do. So let me tell you some other things you could do. You could take advantage of the fact that in C++ we have pointers, not just only references. And you could have a pointer in your class that pointed to the cache, and the pointer is const. You can follow it and change the numbers that live at the end of the pointer all you like. That does not violate const correctness. Okay? That's an okay thing to do. I'm not crazy about it. I'm especially not crazy about it in our new world of if you're typing new and delete, you're doing it wrong. Because where did I get a pointer from? Right? Clearly it's not the address of something, because whatever it's the address of would also be const. So it has to be something that I got from the free store. So who's calling new on it? Who's calling delete on it? What happens when you copy a stuff? Let's use a shared pointer. Let's use a unique pointer. Oh, unique pointer, what happens when you try to copy a stuff? And a lot of this complication you actually should think about. Like, what does it mean to copy one of these things around? And do you copy its cache with it and all that? They're actually valid questions, but they add complexity. So my favorite, just go back into your header and make it tell the truth again. Make these two variables mutable. Right? So mutable means I'm exempt from const. And now only those two guys are exempt from const. So get value is still marked const correctly, and get value cannot change number 1 or number 2. Nobody needs to read your code to understand where you're telling the truth and where you're lying. The whole story is here in the header file, and we could just live happily ever after. And that's why they're able to say, don't cast away const. Find another way around your problem. I never liked reading const-casted code because of all the capital this points to stuff. It's harder to maintain, and then you have to explain to whoever's going to take over for you why you're lying here. And I never felt good about that either. So you want to stay const correct, especially in the world of now. Right? We've got all kinds of performance issues and threading issues and things like that, where being const correct has real everyday value in your code. Do not say, oh, I'll just make the compiler happy and take the const off. Don't do that. Never transfer ownership by a raw pointer. Can I show you what this doesn't say? It doesn't say never use a raw pointer. People ask me how to do things, and sometimes there's a really obvious use case for a pointer, and they say, but I was told we don't do pointers anymore. And they're like trying to decide between a shared pointer and a unique pointer for something that very obviously needs a raw pointer. This guideline does not say never use a raw pointer. What it doesn't want you to do is this, and I think we've all met this code in our life, right? This thing news up a policy, whatever that is, and returns the pointer, and then its own local copy of the pointer obviously goes out of scope, so this guy's not cleaning this up, and whoever calls it has to know that it's their job to clean it up. Sometimes, if you are lucky, the person who wrote this function has put words like alloc or create, right, or new in the name of the function. So it might be called alloc policy and price it, something like that. But very often not. And so you find out by the dreaded comments, which no one reads, or by a person writing you a note on page 72 of a 100-page document, both of which kind of suck. In this universe, in the 2017 universe, probably the best thing to do is just return it by value. Just create it on the stack and return it. There's a really good chance that it'll be deleted, and if it isn't, maybe you don't even care about the copy so much. I keep meeting people who are all worked up about saving the copy, and their string is, their class has got like a string and 2 ints. It's going to be exhausting when we copy those. It's going to kill us, you know? There are places where copies are really expensive. I did some things with simulating oil refineries and collections of numbers representing the chemical composition of a piece of semi-refined petroleum. We might have a couple of hundred doubles or floating points representing the fractions of different things, but more importantly, you had to do something called flashing the stream, which is a very expensive calculation about vapor and liquid. And you don't just randomly copy those. But your employee with a first name and a last name and a salary and a hire date, we can copy that. It'll be okay. And anyway, the compilers are getting better and better and better at not copying that. So that should be your first thought. Why am I putting that on the free store at all? Now, a thing about me, and it's also a thing about the guidelines, why am I X does not mean don't X. Right? It means tell me why you're doing that. And you may have a reason, like it needs to have a longer scope and outlive and blah, blah, and that's fine. If you want the caller to explicitly allocate it, you could take it by a nonce-const ref and then change it. I don't like it when it's not an in-out, though. Like if it really were to be a pure out, I don't like pure outs. So let's use a smart pointer. So now the function will still be causing something to be allocated out on the heap, but it's going to give you back a unique pointer or a smart pointer, a shared pointer, or whatever's appropriate. It's okay. It's probably the best choice if you have control over what the function does. You now have to argue about when to use which pointer. Correct answer is not. Shared pointer is easier, so use that, by the way. There are guidelines about choosing between unique and shared. If you can't change the API, you can annotate the API. And this isn't going to change anything's behavior, but it's going to change your head. Okay? So there's a template called owner. I will show you the entirety of the code for owner. It's not exactly computationally intensive, right? You can only make an owner of a pointer. That's what that enable if stuff is. Don't worry about spinning. So you can't make an owner of an int or an owner of stuff, but you can make an owner of stuff star or policy star or employee star. And then it's just an alias. So if you're calling something in someone else's API and you need to declare that it returns a policy star, you can declare that it returns an owner of policy star, and that will collapse down to being a policy star, and so you're fine. Your declarations will match. But this tells the person who's making the call, you own what you get back from that. And it also sets up the possibility for checkers to say, you have an owner of policy star here on line 73 of this file, and you never ever delete that, and you let it go out of scope. And then the checker can tell you that you've messed up. Whereas an ordinary raw pointer, the checker has no way of distinguishing false positives, of telling you, hey, you never deleted that. It's like, I don't need to delete that. I don't own it for lifetime. I'm just looking at it. So this way you're marking everything that you actually own for lifetime. When Java first came out, we used to say, Java people think that memory management is too important to be left to the people, and we think it's too important to be left to the computer. I think it's too important to be left to people. It's too hard, okay? So when you are calling a function that gives you a pointer and you have to remember to clean it up, that is too hard. Let's not go shopping, though. Don't return a pointer, return a smart pointer, or at the very least, leave yourself an actual in-code, compilable, real note that you have to clean it up. So there's parts of the language, we don't go there anymore. That's great. Is anybody getting new standard fatigue? Oh, you see, you're slow to put your hands up because you're like, do I want to admit that? When 11 came out, it was so exciting. Oh, look at the toys we get. This is great. And 14 is like, what's a bug fix? To 11, that's good. We forgot some stuff. That's fantastic. 17 is like, wait, I have to learn more new things? I'm not sure I've completely learned all the old things yet. So some of the guidelines are telling you to use some things that you maybe didn't know were there, or you've heard of them, but you don't know what they're for. So I picked up a couple of those. And this one, I'm going to slightly disagree with the guideline. The guideline says, to return multiple out values, prefer returning a tuple or struct. Now, I totally agree that you shouldn't have multiple out values. It's just the order. I don't want to say tuple first, okay? So here is something with an out value, okay? It takes one real parameter and one for writing an answer into, and it returns one and it writes one out. I'm going to have to fit my code on the slide, so it's not exciting. Insert whatever legacy nightmare you currently live with. I'm sure you all have one. So, if I want to call it, I have to allocate the out param first, and I've given it a value because otherwise my tools will yell at me and say, oh, it's uninitialized, blah, blah. So the value doesn't really mean anything. and then I call the function. Meh. Oh. There's a design issue here, right? Who decides when they're not called 1 and 2, which things really are the out value and which are the return value, or which 7 things are out values and which is the return value? So I was prepping these slides. I went and asked a few people. Got 3 different answers, and all 3 answers started with, it's simple, it's obvious, you just. So that's good. Okay, so for future reference, not that I ever want you to have out params, it's simple, it's obvious. You must, if you have a success fail, if you have a bool, that's what you got to return. So that you can say if, foo, and then inside the if you can unpack the outs. Or it's simple, it's obvious, you just got to, whatever the name of the function is, like if it's called price, it must return the price. And everything else, the success fail, the error message, whatever, that's just baggage, that should just be out params. And then, presumably from the people who had multiple children and didn't want to pick a favorite, return void, and everything is an out param, and that way no one will forget to unpack anything. I hate them all. So my number 1 choice would be your own struct, right? You can only return one thing from a function, that's true. That doesn't mean there's only one value you can return. Return a struct. How hard is this? So here's a fascinating and useful struct, which you can see took me hours to write. And that's the only flaw in this, okay? If the struct you're going to return could be called employee, or purchase order, or nuclear reactor condition, then this is a great solution. But when it's going to be called 2 numbers, or 3 ints in a string, it's not so good. Come on, who's written something called 3 ints in a string? I'm not the only one, right? Yeah, thank you. Anyway, the way you call it, you can construct it on the return line if you want, and the only downside is having to have these things to pull the struct back apart into afterwards, or else you have to go around saying dot, like when you're using pair and you have to say dot first and dot second, right? So you have to know the names of the pieces of the struct. And again, it's pretty easy to know the names of the pieces of the struct when it's an employee or a nuclear reactor condition, and it's harder when it's called 2 numbers. Someone's having more fun than me. So I want to take a side trip to stood optional, because very, very common pattern is that the 2 values you want to return are a bool, success fail, and a thingy, right? And the real purpose is to return the thingy, but you also need to indicate whether that thingy is usable or not. And a lot of people, that's why they want to return a pointer, because pointers can be null, not for anything related to lifetime. Stood optional is a great drop-in for that. People who are not me and are not you have slavishly created all of the things that you would have eventually gotten around to adding to your own struct for this. So if you just cast it to a bool, like you say if foo at stuff, that's going to cast it, right? The bool that you get is the usable or not, true or false part of the optional. If you try to cast it to, what were we dealing with originally? I think a policy, maybe, or a stuff, or a nuclear reactor. The operator equals will go get the value out of the value part and put it in the right place. And you can even talk to it as though it were a pointer and dereference it. It is not a pointer, okay? It is not on the free store. It's not the address of anything, but you can call star on it or points to on it, and you'll get things out of the value as opposed to out of the optional. And probably my favorite, value or, right? Call some function that might give you a string. If it gave me a string, I want the string. If it didn't give me the string, I want quote, quote. That's what value or does. Or it might give me an integer. And if it didn't give me an integer, I want 0 or -1 or something. That's what value or does. So for that particular pattern where the 2 things you want are a Boolean and a thingy, go with stood optional. And if you really want 2 ints or 3 strings and an int or whatever, then tuple is your friend. If there's no value to this struct afterwards, and if you can't come up with better names for its pieces than indexes, then you want to go tuple. Because it's been done, right? Why do it? So I know that a tuple with 2 things would be a pair, but I decided I would do a tuple with 2 things anyways. So here is our version of foo that returns a tuple. And it uses make tuple to, well, make a tuple. I'm sorry that the language has become easy to understand and sensible like that. It takes away some of my value. You know, it should be called pushback so that I could explain where historically that name came from. But anyway, so we make a tuple and that's what we return. Life is good. Now, once upon a time, there was this thing with get and angle brackets where you put numbers in the angle. I'm not even showing it to you. It's horrible. You can use tie to tie two local variables, in this case, answer and number. The tuple will get unpacked into those parts. Life is good. Okay? If you live in 17 land, you can use structured bindings. And now you don't even have to declare them before the call. And this is really sweet, right? Answer and number will have the correct type. In this case, they'll both be ints, and they're declared right then and there when I make that call. And I think this beauty is partly why the guideline says prefer a tuple or a struct, because this is so sweet, you want to tell people to use it, okay? But I'm going to say prefer a struct or a tuple, because if you have a real name for your struct and real names for your fields, and it's an actual useful abstraction, that should be your first choice. But if it's called 3 ints in a string, then go ahead and make it a tuple. I made a tuple of int, but for those of you who haven't met this before, it's any and all types, right? No restrictions. So it could be int, string, int, or what have you, it doesn't matter. One of the problems with outparams is knowing when the function is done. So it's all very well on slides, but in the real world, I think my record is a 15,000 line function. I met something with a 1,000-line catch block once. When you have a multi-page function, and somewhere 17 or 18 lines in, it says x equals 3, it's like, is that it? Is that the answer? Are we touching x ever again? You don't really know. When you have a return statement, it kind of stands out. Even if you have many return statements in the function, they all kind of stand out. So if you have return make tuple at whatever, that's when the values are being sent back, and you know that. And I find that has a huge benefit just for reusability. It also makes your signature now carry different meaning. So now when I see a non-const ref parameter, I know it's an in-out. I know it's not an out. When I see a const ref parameter, I know it's an in. By taking out params out of the maybe, I can be confident about what I'm seeing in the code. So this is a lovely guideline and also a reason, if you wanted one, for why you should be using some 17 features. Who's used class enums yet? More than have used an actual guideline, that's good. For everyone else, here is an enum class. It looks exactly like an enum except it has the word class in it until I define another one. And then we pull off this miracle trick of having two values with the same name. You know, most of the unreadability of our old code is that all our OKs are called like SOK, FOK, DOK, and so on to distinguish them from all the other OKs. And then it would look weird if I had terrible, ROK, terrific, so they're called R terrible, ROK, R terrific, and so on. And then people complain our code is hard to read. You can mix and match with old-style enums. These are, for those of you like me who are not American, American states that happen to start with O. And you use them with their full names. So that's why I've called them out in red. With the old-style enums, you now can use them with their full names if you want to. It used to be an error to do that if you weren't on Visual Studio. It used to confuse the life out of me when I would take my code to another compiler and go, why can't I say what it's part of? Well, now you can if you want. And the most interesting thing about these guys is kind of hidden here in the last line of this slide. You know, most functions that took enums didn't take enums at all, right? They took ints. And I don't know why, it just became a habit of ours. And so the compiler would be like, oh, that function wants an int and you're passing it an error, okay, terrific. Except that it was actually expecting a ratings okay, and you just had a mind slip and you passed it a very different numerical value than what it was expecting. So you think, you know, you're passing down 1 and you're actually passing 17 because you use a different enum. And then the function goes off and does whatever it does for that wildly different enum value. So with the enum class, you can get it to an int if you want by static casting, which is the it is my foot, and I'm pointing this gun here on purpose, operator. but you can't do it accidentally as you can on that last line. I was arguing with someone the other night, and we're saying the problem with C++ is our early defaults are mostly wrong. Like what's public and what's private, and implicit conversions and that kind of thing. And you have to say explicit if you don't want it to be used for conversions. And implicit conversions back and forth between enums and ints may have saved us some time occasionally, but if we add up all of the bugs that we've chased over our lifetimes, not so much, right? So that's, to me, the big deal of the enum class. But the immediate benefit is you don't have to call things ROK, SOK, EOK, and whatever. You can just have the names you want. Oh, and in theory, well, I mean, I know it's true, I've just never done it. You can have a different backing type. Like, especially you can have a smaller type. I've never had need for that. But should you, that is also a choice. I briefly mentioned the guidelines support library when I showed you owner. This is not the guidelines support library. This is a library in Dublin. It's gorgeous, though. In writing the guidelines, they got to places where they wanted to show you little snippets, like, say, owner. It's 1, 2, 3 lines long. But rather than putting that textually in the guideline and say, consider writing a template like this, they went off and designed the guideline support library. Anybody used anything from the guideline support library? Well, that's really now my record. That's 5 hands out of this whole room. What can I tell you? You are not the first developer with this problem. So I thought I would pick out 2 guidelines related to the GSL so that you understand that it's a library that maybe you want to go look at. A pointer that must not be null. Have any of us ever met a pointer that must not be null? Gee, does that ever happen? Imagine some service, S. I'm going to take its address and then use that to call do something. The sort of code that only ever appears on slides, because why wouldn't you just have said s dot do something? I know. But you know this is safe code, right? There's no way that PS is null. Unless, of course, I were to set it to null pointer, and then immediately try to call do something. And what will happen? I will get a null pointer exception. And if all our null pointer exceptions look like this, my hair would not have any gray in it. So you need to call if the pointer isn't null, blah, blah, and that's really boring, so you write like a little helper function, right? Ask the service to do something, which is all fine till you get to the part after the if. Like, if I can't return p points to do something, what can I return? Should I throw an exception? Well, that's kind of stupid. I'm doing this so I won't get a null pointer exception. If I was okay with catching an exception, I could have caught the null pointer exception. So that's not okay. Well, remember we were talking about value or for stood optional. So maybe it's like, hey, if the service can't help me, then the answer is 0 or quote, quote, or false or something. And if you have a legit signal value and you don't care that this pointer somehow got null, then that's an okay pattern. But usually, that's not the case. And when that's not the case, the pointer cannot be null. So this ask pointer to do something is fine if it's okay for the pointer to be null and we can deal with that and we'll just say 0. But what about when you can't? So you include the GSL header, and the GSL is a spec, right? There is an implementation by Microsoft under Microsoft's GitHub instead of under the ISO CPP GitHub, and there can be plenty of other implementations as well. And it's header only, so you can just download it and put it in your code and carry on with your life. So now I'm declaring PS to be a GSL not null of service star. Everything else about PS is utterly unchanged. I'm still initializing it by taking the address of S, for example. I'm still dereferencing it with the exact same operator. Everything you think is going to happen is going to happen. But it is not just an annotation like owner. This last line of code on the slide, PS equals null pointer, it's a compile error. Do you know how much I love that? It is I tell people the compiler is your friend. There is no better time for the compiler to be my friend than on this line of code. Here is a pointer that should never be null, and I'm setting it to null. What is wrong with me, right? So the compiler will actually, because they've suppressed various constructors, you get a compile error. You can't do this. That's great. But you know, you can lie to compilers. You can hide things in different translation units. So I wrote a function called getPointer, which could be doing something super clever, but which in fact just returns whatever it's given. And then back in my place where I declared my not null service pointer, PS, I see PS is equal to getPointer at null pointer. And then we all know what happens. The program carries on about its merry way, and a year or two later, somebody happens to click some button and you still haven't put a decent value into PS, and then we go boom, right? No. I mean, you would, except that you went boom on the line that set PS to null pointer. So if it can't be a compile error, it's a runtime error. Not when you use it, but when you foolishly set it to null. And that's the line you wanted to find, right? Because people are phoning you and sending you screenshots of their null pointer exceptions, and you're like, okay, I get it, it's null, but how did it get null? Who did that? And you're like searching your code base and setting weird memory-based breakpoints and everything else, and it's a really hard thing to find. So here, you'll get a runtime error when it gets set to null. And you will know what line got you there, and if you're the one who's running it, you can maybe look at the call stack and see what happened and blah, blah. So you can actually solve the problem. And that's all that takes. If the pointer's not supposed to be null, mark that it's not supposed to be null. This will actually make your application faster. Do you know what all those if the pointer isn't null are costing? And you're doing them every single time because you know in your bones that if you leave one out, you will get got. So you can take them all away. And of course, you're being expressive. You're saying this is a pointer that is never null. So you don't go boom, you're faster, and everybody knows what you're saying. Most of the guidelines are like this. It's not a trade-off. It's not like, do I want this or this? It's like good, 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 good versus what we have now. I'm going to go with good, 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 good. Now, this guideline is more generic than what I'm going to talk to you about. The guideline in general says try not to do narrowing conversions. And you notice, unlike don't cast away const, it's like avoid. We're back to the you might want to consider if it's possible and convenient, right? But within there's a little piece of the description that mentions narrow and narrowcast. First, I want to show you, this is some of my own code. I wrote it a very, very long time ago, but I was able to find it in a heartbeat. Some of you will recognize some of these types. You'll be like, oh, the poor dear thing. She's on Windows. She's on Visual C++, because you can tell by the warning number that I have to disable. And I got no control over any of this. I'm being a thunking layer. I'm getting the pieces of time out of an input time, which keeps its bits and pieces in signed ints, because if you need to represent a number between 0 and 59, a signed int is the obvious choice. And I'm putting them into system time, which wants everything in words, and it is possible that some ints won't fit in some words, but it's not possible that 0 to 59, 0 to 23, and so on will not, right? So these are narrowing conversions, which we are urged to avoid, but which we often cannot. I have pragmaed away the warning because I live with warnings and errors, and I want 0 warnings, so I have to pragma away them, and then it's my personal convention that I tell you what I'm pragmaing away. In this case, is the possible loss of data, and then obviously in real life the line doesn't wrap. Seconds and whatnot cannot be too large for a word, and they will always be positive. But compiler doesn't read comments. So, narrowcast and narrow, which are not in the standard, they're in the GSL. They're just like, say, static cast. Right? I'm going to narrowcast to a word. Just seeing the name tells the person who reads your line of code that this is a narrowing conversion, as opposed to any other kind of randomly chosen conversion that you're doing. So that's good. The one that's easier to type is a little slower because it does a little more. Say I have the number 200, and I want to put it in a type that can hold -127 to +128, a case you may have found yourself in by mistake. I can do that cast, but when I am done, it doesn't have the value 200 over here. Right, it has -70 something, right? Narrow checks after the cast if the new value and the old value are equal. So if I'm trying to put 200 into something that can hold 0 to 255, afterwards it's still 200, they're equal, we're fine. But if I'm trying to put it into something that holds -127 through 128, afterwards they're not equal, and it either terminates or throws. You can control it with a macro. But I'm going to say it throws. So you get a runtime error. You have attempted a narrowing conversion that didn't succeed. It wasn't okay. All your assertions that this will be a number between 0 and 59 and it'll totally fit in an unsigned short are not so true after all. Ha ha on you. Narrow underscore cast is more work to type. It just trusts you. Okay? It just happens. You might lose data. When you type narrow underscore cast, you are saying, I might lose data and I don't care. Do not come to me if I lose data. I'll do that for the times, because if we ever come to second number 73 of a minute, I got bigger problems than whether or not my code is working. But the default one, the one that's easier to type, will check for you and look after you. So again, you're expressing your intent, and you may even get looked after and be told, actually, your reasoning is wrong. It's probably a good idea. So here are my 10. They're not the top 10. They're not the best 10. They're not the easiest 10, but they're the 10 that I chose to illustrate these 5 reasons. Don't argue about the bike shed. Don't spend your entire code review about whether or not to use default parameters. Don't hurt yourself with the spiky bits and the dangerous dark corners of the language. Forget certain things entirely. Just because we did them in 1990 does not mean it's okay to do them now. Please do learn the new things. We're adding new things for a reason. They're elegant and they're beautiful and they solve real problems. Use them. And then take a look at the guidelines support library. It has other things in it besides this. There's span, there's all kinds of fun things happening in there that have real value and that will, I am sure, bubble up eventually. What I would like you to do, I'm not asking you to read the guidelines. I'm asking you only to bookmark the markdown document in your browser. Okay, that is 10 seconds out of your life. Then someday soon, you have a decision to make. Someone asks you a question, and you're like, should I A or B? I wonder if the guidelines has an opinion. And go and look and see if it has an opinion. You know, like search within the browser or follow the headers or whatever. And if it has an opinion, consider following it. That's all. I believe if you do that 2 or 3 times, you're going to say, you know what? I wonder what's in here that I didn't search for yet. And at that point, maybe you will read it top to bottom. Because by that time, you will know there is something in it for you. And that's really my take on the guidelines. They are going to help you make decisions more quickly and make better decisions, which again, usually you have to trade off between those two. But if you say, okay, I'm going to go home and read the whole thing, don't do that. Get your benefit first, okay? Then once it's a proven situation to you, try reading the rest of it. Now, the other thing is there are slowly coming out checkers. So you can just point them at your code base, they'll go blah, and they'll give you guideline numbers and say this is breaking F21 and this is breaking E3 and so on. If you're up to it, consider that. But again, maybe after you've had a chance to see that a few of these things really are advocating for what you think is the right thing to advocate for. And with that, yes, indeed, I have some time for questions. Thank you.
Hi, do you want to go back to not null? So you said there's no trade-offs on this, and that's not true.
What don't you like?
I don't like not null at all. I really like owner. Owner disappears.
Just a name, yes.
Not null violates sort of one of my basic ideas on type design, which is everyone really, really wants there to be transparent types. Like, this is not a service star now.
No, it is not. It is not. It is a service star that cannot be null. Yes.
Right. It overloads specializations, conversions, all behave differently now. And the more that we try to layer things into the type system that are questionably actually types, there's a dark and difficult path.
But a unique pointer is not a service start either.
Right.
It overloads all that stuff.
Right.
But we've embraced it because of what it brings us.
Yes.
And null pointer exceptions are in some ways worse than memory leaks, because once they happen, boy, you're done.
True.
Right? Whereas you could leak for quite a while and be okay.
Right.
So.
But now we have not null T. Presumably you also want not null unique putter. What's left in that when you move from it?
Yeah, okay.
Type that can't maintain its own invariance.
Yeah, that's interesting. The intersection of not null and move is an interesting intersection. I'll grant you that.
Right? There are very good reasons to try this, but it is something that should be approached with a little bit of caution and awareness. So I don't think it's fair that there's no trade-offs here.
All right. I will, yes, especially if you're as smart as Titus.
Since we are bike shedding the rules, could you please repeat the tuple versus struct slide? The one which you showed the tuple in action. Yeah, this one. So basically, this should really read return a struct, return a struct, return a struct, only if you're doing that template mega programming and you need to build it up.
Right. My first choice is the struct. If you can give the struct a good name, return a struct.
Yes.
The guideline says tuple or struct. I'm like, no, struct or tuple. But I don't know that we're gaining anything by filling your program up with structs that are called 2 ints, 3 numbers, da-da-da-da-da. I'm okay with using something generic then.
Don't give them names.
Don't give them names, and that's what a tuple is when it doesn't have a name.
But the tuple, my concern with this is the tuple you keep using the same tuple type everywhere, a tuple of 2 numbers for representing a point, for representing a complex number, for representing a side. That's bad. Now you have different things.
Right, because those are abstractions, they are points, they are complex numbers, whatever. That's why I think, in contrast to what they say, struct should be your first choice, tuple should be your fallback.
Yeah.
Yes.
And it's just such a shame that tuples implement the tuple protocol on its own. And for doing that slide, using a struct, one needs to write another 3 slides of boilerplate.
And that's why it appeals. But if you can give your abstraction a name like point or complex number, that should be your choice, 100%.
Actually, I would say even if you don't give it a name, just write the struct before the return type of the function. That's it. give your struct meaningful names for the members, not for the struct type. And you have that. It's right there. So
number 1 and number 2, or in this case, answer and number.
It's written right there. Yeah. Because when you're going to use a tuple, you're going to decompose it that way. Those are your members, right?
This time. But when it was the point and the complex number, the pieces had different names then.
Well, you are going to decompose it with a structure binding. You're going to call it X and Y or whatever, real imaginary. Do that, please. Thank you.
Okay.
So I have a question on you suggested mutable instead of const casting. So maybe I've been doing things wrong my whole life, but it feels like someone sticking mutable on a variable I usually make an assumption when I see a const where I don't have to worry about things like threading. And so doesn't that open up a different problems when someone's saying, oh, I got a const method. I can just call it on thread 1 and thread 2. I don't have to worry about it. But if
so that's why it's good if you've got this in your design, that in this const function get value stuff changes. When you tell the truth in your header, then the person who's trying to use this class in a threading situation sees, I've chosen red, so literally sees a red flag. When you don't have mutable in your header, but you just cast away const inside the function, nobody knows how horrible you're being, right? So I'm not arguing that it's not horrible. I'm saying tell people that you're horrible.
Okay.
Fair?
Well, there's usually you don't see all the headers. Usually you see a library, you get one header. And
Right, but
that
headers you
header
can at least see compared to the actual implementation you will not see.
That's true.
So tell the truth, own your stuff.
So when going to the guidelines, to the GitHub, do you have any tips on how to formulate a search string when you have a problem and wonder whether the guidelines have any guides? Because
That's actually non-trivial. So I start usually with the sections. So if I'm thinking about constructors, there's a whole section on constructors, there's a whole section on classes, there's a whole section on expressions. And when that works and then I'm just searching, I tend to search mostly for language keywords, like return. And yes, you'll get a lot of false hits. I get a lot of false hits. Don't search for const in that markdown. You'll be there a long time.
Thanks.
I'm sorry I didn't have enough slides.
That's okay. So you said never cast away const. And did you really mean never?
So I have all kinds of rules. Don't help without asking, right? But if someone's unconscious, you help them, right? Let's say never, and then you only really will if you absolutely have no other choice at all, which is very rare.
Right. And the situation I'm talking about is very rare, but if you have something like an element ref, and you want to implement it in terms of a const element ref, and you want to reuse the same pointer, and you know when you construct it.
Your own little mini memory management.
It's all in the same header file, and you're just doing stuff because you don't want to use up a user-defined conversion.
So if you've proven to me that you're not optimistically optimizing when you didn't need to, that you actually have a reason for having to do that, then that might be an exception.
And there's also a really wicked bug, because if you do that kind of thing and you're not really careful about rebinding the references, then you can introduce something you absolutely had no idea you were doing.
Right.
So the advice
because
is really good.
Taking away off the safety belts, and then you might fall off the cliff, but sometimes you have to do it.
You should probably assume when you do this that you've introduced a bug, and you better test the bejesus out of it.
Always a good rule. Hi. Last one.
Hi. When we learned about the keyword auto, we started using it everywhere.
Almost always auto.
Soon enough, we ran into issues. I wondered if you have practical suggestions on when we should use auto, when we should prefer type def.
Oh, and we're already over time? That's probably an hour. We'll talk one-on-one, okay?
Sure. Okay.
Thank you, everyone.
Thank you so much.